Alright, I'm going to try to compare the next side with this. We can see that the total here was 1. And it's after we apply our ratio, right? After we multiply by our ratio that things start to become a piece of that total, right? This is my ratio applied twice instead of all the pieces. This is my ratio applied 3 times instead of all the pieces. So if you look at here, we're going to say the sum right here is all the pieces, right? That is, we're going to begin by writing the series as A plus R plus A times R squared all the way to A times R to the n minus 1. Now when we apply our ratio to this, and that's just saying, hey, you know what? Take this and multiply that entire thing by R. So A becomes A times R, right? A times R, this is bringing R into everything, right? That's saying take this R and distribute it to everything. That becomes AR squared. A times R squared becomes AR cubed, and so on, right? And we end up getting into this A times R to the n minus 1, right? But we go one further. We multiply that by R, right? So that turns into A times R to the n. I'm just going to show that real quick. If I took A times R to the n minus 1 times R, that's really R to the first, right? If I multiply this by R, and look what happens. Keep your base and add. Well, this negative 1 and that 1 cancel off, and that gives me AR to the n. Now, this is kind of hard. You might want to wrap your head around this a couple times today. But if we multiply that expression by R, this expression, we get this. And depending on how many times we apply that ratio, fills in these dots. All right. So now, what we're going to do is this. We're going to find an expression that says, hey, you know what? We're going to take the total and subtract it by R times that total. And here's what it looks like. All right. I'm going to set this up vertically. All right. Let's start off with this. That's going to be A plus AR plus AR squared, dot, 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 dot. We end up with A times R to the n minus 1, right? That's this term, which we got right here. And from that, we're going to subtract. So I'm going to subtract this term. Well, there is no A on that term. So we end up subtracting AR, right? That's right here. Then AR squared, and all these terms are going to match up, right? They're just going to be moved over. This matches up with that matches up with that matches up with the first term in here. So I'm going to say dot, dot, dot. This, right, A times R to the n minus 1 matches up with that A times R to the n minus 1. But we also got this. We also got A times R to the n. All right. So if I subtract all of that, right, if I say, hey, this minus this, well, my sum minus my ratio times my sum is equal to, well, all these cancel out all the way down, even that one. I've got an A minus AR to the n, and that's what the sum is equal to. Now we're going to play with that just a little bit more. All right, we're going to do a little bit further than that. We're going to come up with an equation from this. And I do understand that this is a lot of thinking, and when we apply this, it's going to be a whole lot easier. But let's go through and do this. This is good mental exercise. So if I wrote that, we know this. We know that Sn minus the ratio times S, I put that parenthesis in the wrong spot, equals A minus AR to the n. So let's factor. Well, what factors out of here? Well, it looks like S of n factors out. So I could say, hey, you know what? Let's say Sn, right? And if I factor that out of here, that's 1. If I factor that out of here, that's minus R equals, looks like A comes out of here, right? A divided by A is 1. AR to the nth divided by A is R to the nth, right? And then I want to subtract for this, for the sum, then my literal equation, all I do is divide both sides by 1 minus R. I divide this side by 1 minus R. And I get this. I get the sum of this series, with n as an input, is equal to a times 1 minus r to the n over 1 minus r. And this formula, and let's write what it is, a equals my start, right? R equals my ratio, and n equals number of terms. That is going to be my equation that we're going to use on all the rest of these problems to find out the sum of a geometric or a finite geometric series. I'm going to go ahead and turn this page so you can actually see it. All right, let's write this down. Okay. So we have this formula. Let's check it with that first one. Ready? So here it is. I'm going to rewrite it. Ooh, let's pull it down here. All right. We've got the sum of a series is equal to my start over 1 minus r to the n, 1 minus r. All right. And let's try it on that first one. Remember our first term on that equation? So my first term on that equation was 1/2. My ratio on that equation was also 1/2. I'm talking about that first explore that we did. I'll even show you the first explore that we did really quick. All right, if I can find it real fast anyway. On this one, I started at 1/2, and each term I added half again. All right. And if we do this, here's our equation. We've got S of n is equal to my start of 1/2, right? 1 minus 1/2 to the nth power over 1 minus 1/2. If we write that out, that is equal to 1/2. And then we have, well, 1 minus 1/2, we'll put that in parentheses, to the n over 1/2. And then we can see that these two cancel out, and I literally get the same answer we figured out before, 1 minus 1/2 to the nth power. And if you remember us writing that back here, I'll show you that when we use this, all right, we actually ended up with the same equation right there. So when we did it visually or when we did it with our equation, all right. Now I want to point out something right here. This is saying what can't r equal? Well, r can't be equal to 1, can it? Because if I made r equal to 1, that would turn into a 0. So the ratio cannot equal to 1 for this equation, all right? Because then our denominator would equal 0. I'm going to pause this. We got one more go with this. Looks like we can finish this next page on the next video. And good work. If you could, watch this again. There's a lot to absorb. And something like this, you have to plug into your brain more than one time. I'll see you guys tomorrow.